So explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So this is the question given here and we need to prove these are the composite numbers. Yesterday we learned about what are prime numbers and what are composite numbers. And what is the prime number? Prime number is the number which will have two factors, it is 1 and itself only. And coming to the composite numbers, the numbers which will have more than two factors are called as the composite numbers. So our criteria in this query, we are going to prove that these types are composite numbers. Okay students? So let us see here. Let us take the first part here, that is 7 into 11 into 13 plus 13. When you observe here in the first given type of numbers, what is given 7 into 11 into 13 plus 13 is given. So what can you observe students? What is the common number which has been presented in these numbers with the operation called as what your addition operation, and this comes under the multiplication. So what is common here? 13 is common. Just take down that as common, 13 as a common. So you will be getting 7 into 11 into 1 plus 1. So what is that one? That is 13 into, what is 7 into 11 students? 77 into 1 is 77 plus 1. That is 13 into 77 plus 1 is how much? 78. What is 13 into 78 students? Let us do the multiplication here. That is 78. 8 is 24. 8 ones are 8, 10. Then 7 is 21. 7 is 7 plus 2 is 9. 4, 1 and 10. That is equal to 1000. That is 1014. Okay students. So that means here you have that that you have to prove that these two are composite numbers. So we got 13 into 78 as 1014. But we know that according to the fundamental theorem of arithmetic, what is fundamental theorem of arithmetic states that every composite number can be expressed as a product of two prime factors. Okay, but by FTA, that is fundamental theorem of arithmetic, every composite number can be expressed as a product of the prime factors. Okay students, now coming to the second part. This is the first part is over. So what is the second one here again? That implies 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Again when you observe here, 5 is a common here. Just take it 5 common here. So 7 into 6. So what is common here? Take out that 5 to the common. So you will remain with what? 7 into 6 into 4 into 3 into 2 plus 1. Why? Because we have taken already 5 as the common part. So let us simplify that. Is 5 into 7 into 6 is 42. 42 into 4 3 is 12. 12 2 is 24 plus 1. So what is that one? 5 into 42 into 25. Because 24 plus 1 is 25. So let us check that here. 42 into 25. What is that one? 42 into 25 means 5 to the 10, 5 4 the 20, 21, 2 to the 4, 2 to the 8. So 5 and 10. That is equal to 1050. This is 1050. So again what is 1050 into 5? 1050 into 5 is 0, 5 5 25, 0, 2 and 5. That is 5250. So here also we can conclude the same thing, like how we conclude that by FTA. That is, what is FTA, students? Fundamental theorem of arithmetic. Every composite number can be expressed as the product of prime factors. So it is a composite number. How can we say that it is a composite number? Because it is having more than 2 factors. Okay, the same conclusion we are going to conclude here. Okay, therefore by FTA, every composite number can be expressed as a product of prime factors. Okay, students, this is our problem. Okay, students, for this type question, whatever we have proved that is, this type of questions will come from higher order thinking questions. In that type of question, this will be helpful for 2 marks question for your examination point of view. What is the next question? How will you show that 17 into 11 into 2 plus 17 into 11 into 5 is a composite number? We need to explain it. Again, same thing like the previous problem. That is, what is that given question? 17 into 11 into 2 plus 17 into 11 into 5 is a composite number. When you observe in these 2 terms, what is common here? 17 into 11 and 17 into 11. With the binary operation called as the addition here. So let us take the 17 into 11 to be the common here. So the remaining thing you will be getting as 2 plus 5. So what is that 17 into 11? If you take 17 into 11, just keep down. What is going to get? 1 7 is 7, 1 is 1, 1 7 is 7, 1 is 7, 8, 1. So that is 187 into 7. If you take 187 into 7 again, 7 7 is 49, 7 8 is 60, 7 1 is 7 plus 6 is 13 not 9. So that is equal to 13 not 9. Like in the previous problem, we have dealt about FTA. What is FTA, students? Once again, fundamental theorem of arithmetic. What is that fundamental theorem of arithmetic? Says that if a composite number, and when can you call as a number to be a composite number? A number can be expressed as a product of prime factors, then it is called as a composite number. So the same thing we are going to write here. Therefore, by using FTA, that is fundamental theorem of arithmetic, if a number can be expressed as a product of prime factors, then it is called a composite number. So this type of questions is again useful for your SSC public examination. It will be giving you for 1 mark question. Okay. Okay, students. The next important question is, what is the last digit of 6 to the power of 100? This is again a very important question for the examination point of view for 1 mark question. So just listen here. What is the last digit of 6 to the power of 100? So we will start with 6 to the power of 1. Here we will given. What is 6 to the power of 1 is equal to 6. Okay, students. What is 6 to the power of 2? That is 36. What is 6 to the power of 3? That is 36 into 6. That is nothing but 6 is the 16. Okay. 6 is the 36. Sorry. 6 is the 36. We carry. That is 6 is the 18. 21 to 60. That means when you observe the students, the last digit in all the number 6 to the power of any number if you take, the last digit in the unit place you are getting with 6 only. It is terminating with 6 only. Obviously it will be understood that 6 to the power of 100 also will be ending with the last digit 6 only. No? Yes or no? The last digit means the last digit of 6 to the power of 100 is also equal to, also will be equal to following ratio. So the following ratio numbers are going to be terminating or non-terminating. We need to solve that type of problems here. First one is 3 by 8. So this is the rational number. We need to prove that whether it is a terminating decimal or non-terminating decimal. So let us take it here, students. 8 and 3. Okay, 0, 3, 8 won't divide 3. So just put point, put it here. 8 3s are 24. What is the remainder? 6. Already the decimal is there. Put 0 here. 8 7s are 56. 4 0. 8 5s are 40. So when you observe here, you are getting 0. So that means 3 by 8 is equal to 0.375. Okay. Now since you are getting 0 here, we can say that it is a terminating decimal. Terminating decimal. So what is the meaning of terminating? It will come to an end 0. Is the division got ended here? Yes. Obviously it got ended here, so it is a terminating decimal. Hence 3 by 8 is a terminating decimal. Second problem. So this can be written as 9 by, I can write it as in the form of 3 into 5. And this is not in the power of 2 power n and 5 power n, which we have seen in our theorems. Since the expansion in denominator is not in the form of 2 power n into 5 power n, we say that it is a non-terminating decimal. So first, this is a non-terminating decimal. Why? Because in the given problem, the expansion is not in the form of 2 power n into 5 power n. Hence, we can conclude that it is non-terminating decimal. In the previous problem, what would we check? That it was terminated to 0. Hence, it was a terminating decimal and this is not a terminating decimal. So, based on this one, based on those theorems, we are going to solve the problems in this manner. Okay. So, next problem is 13 by 3125. Okay. Let us do this by taking LCM 3125. 5 6 are 30, 5 2s are 10, 5 5s are 25, 5 1s are 5, 5 2s are 10, 5 5s are 25, 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So this can be written as 13 by 5 1 2 3 4 5, 5 to the power of 5, that is 5 into 5 into 5 into 5 into 5, that is nothing but 13 by 5 to the power of 5. Okay, so This is, since we have 1 year, the LCM will be stopped. We can say that this is in the form of 2 power n into 5 power m. Hence, it is a terminating decimal. Next problem, 11 by 12. Take down the prime factors. 2 6, 2 3s, 3 1s. So 2 6 are 2 3s are 3 1s are 11 by 2 into 2 into 3. So when you observe here, 11 by this is 2 square into 3, but it is in the form of 2 power n into 5 power m. 5 power m is not present here. Okay, factors of 5 are not present here. So hence this is not in the form of 2 power n into 5 power m. Hence it is not a terminating. It is not a terminating decimal. So next question is, students, that prove that root 2 is an irrational number. This is very important for your SSC examinations, for essay type questions, where you are going to get for 4 marks question, students. Okay, 4 marks. Okay, now what is the given question? To need to prove that root 3 is an irrational number. In order to prove that root 2 is an irrational number, let us prove that by taking root 2 is a rational number. That means we are proving this by assuming that root 2 is a rational number. That means we prove this by a method of contradiction. Let root 2 is equal to p by q, where q not equal to 0 and p and q are co-primes. That implies root 2 is equal to p by q. Take this as to be the equation number 1. Now what you are going to do, whenever the roots are here, you just square it on both the sides. Squaring on both sides. If you square it on both the sides, what you are going to get, students? That is 2 is equal to p square by q square. I can write this as 2 by 1 also. Now what is the next step? Let us do the cross multiplication here. That implies 2q square is equal to p square, or vice versa you can also write as, so p square is equal to 2q square. That means we can say that 2 divides p square. If 2 divides p square means 2 divides p, I can also say that ultimately we can say that 2 is a factor of p. Okay, students? So that implies root 2 is, once again let us take here, root 2 is equal to p by q. we need to square it on both the sides. So when you square it on both sides, you will get getting 2 is equal to p square by q square. Now when nothing is there, you can write it by 1. 2 by 1 is equal to p square by q square. That is 2q square is equal to p square, or p square is equal to 2q square. That means whatever 2 is dividing p square, automatically 2 divides p. That implies 2 is a factor of p. Okay. Now this p we are going to assign an integer called as 2m. That implies square it on both sides. What you are going to get it? P square is equal to 4m square. P square is substitute that 2q square is equal to 4m square. That implies what is that one? Q square is equal to 4m square by 2. 2 ones are 2. That implies q square is equal to 2m square. That implies if q square is equal to 2m square, then what we can say that 2 divides q square, 2 divides q, that implies 2 is there, factor of q. Okay. So since p and q are co-primes, since p and q are co-primes, then we can say that our assumption root 2 is a rational number is wrong. If this our assumption is wrong, then we can say that hence root 2 is an irrational number. That rational number is assuming to be equal to p by q and q not equal to 0 and p and q are co-primes. Now this root 2 is equal to p by q. Suppose this equation is in the form of roots. In order to remove the roots, we need to do squaring on both sides here. So when you do squaring on both sides, you are going to get 2 is equal to p square by q square. So this p square by q square is equal to 2. When nothing is there, you can write it in the denominator in the form of 2 by 1. 2q square is equal to p square. 2q square is equal to p square. So, or else we can write it as p square is equal to 2q square. That implies 2 divides p square. If 2 is dividing p square here means automatically 2 divides p. Obviously, it is understood that 2 is a factor of p. Now, if 2 is a factor of p, let us take that p is equal to 2m, where m is an integer. Now again, you need to square it on both sides. You take the value of p square, you are going to get 4m square. So what is the value of p square from here? This is equation 1 you take. That is from 1 to q square. Substitute that or replace whatever you call it as, you will get 4q square. Q square is equal to 4m square by 2. 2 1 that 2. 2 square is equal to 2m square. 2 divides q square. 2 divides q. That means 2 is the factor of q. Since p and q are co-primes, then we can conclude that our assumption 2 is a rational number is wrong. Hence, if it is a rational number, whatever we have taken which is wrong, obviously we can say that root 2 is an irrational number. So this completes our problem, which is very important for the examination point of view, students. Next type of problem is to prove that 3 plus 2 root 5 is an irrational number. Same again, we need to prove this number, this type of problems by assuming in the form of 3 plus 2 root 5 is a rational number. That means we are proving it by the help of contradictions. Let 3 plus 2 root 5 is a rational number. That implies 3 plus 2 root 5 is equal to 3 by 2. That implies 2 root 3 is as to be equation 1. 2 root 5 is equal to p by 2. Shuffle this 3 towards the other side. We get minus. That implies you are going to get root 5 is equal to p minus 3q by q. That implies root 5 is equal to p minus 3q by 2q. Therefore, we can say that an irrational number cannot be a rational number. Hence, our assumption three plus 2 root 5 is a rational number is wrong. Hence, we can conclude that 3 plus 2 root 5 is an irrational number. Next important concept here is logarithms. Let us see the definition. For a greater than 0 and a not equal to 1 and n greater than 0 and a comma n are real numbers. Here a comma n are real numbers. Then we define it as if a power x is equal to n, then x is equal to log n to the base a. Let us see few laws of logarithms where you are going to learn these types of laws which will helpful in solving the problem, students. Here let a and x are any two positive real numbers and a not equal to 1. Then first law is log xy to the base a is equal to log x to the base a plus log y to the base a. Next log x by y to the base a is equal to log x to the base a minus log y to the base a. Next log x to the power of m to the base a is equal to m log x to the base a. Next a log n to the base a is equal to n. Why? Because when you bring this one to here, it becomes n. N log a to the base a is equal to 1. Log 1 to the base a is equal to 0. Log 1 value will be 0. Log a to the base a is equal to 1. So log n to the base a is equal to x. So that means we are going to convert it into the form of a power x is equal to n. So if you want to convert it into that form, how we are going to get it? 2 power x is equal to 1 by 16. So that implies 2 power x is equal to 1 by 2 to the power of 4. You can express in this form. That implies 2 power of x is equal to 1 by 2 power 4. So better you shift this to the numerator it becomes 2 to the power of minus 1. Here you write since bases are same, powers are equal. That implies x is equal to what? Minus x is equal to minus 4. So this is our question, the value of x, which is useful for 1 mark question. Log 5 to the base 2. So how can you convert this one? 5 to is equal to 2 power x. Now how can you find that? This can also be written as 2 to the power of x is equal to 512. You are going to find out the factors of 512 by using the prime factorization. 512, that is 2 2s are 4, 2 5s are 10, 2 6s are. Next 2 1s are 2 2s are 4, 2 8s are 16, 2 6s are 12, 2 4s are 8. 2 3s are 6, 2 2s are 4, 2 1s are 2, 2 6s are 12, 2 8s are 16, 2 4s are 8, next 2 2s are 4, next 2 1s are 2, 1 2 3 4 5 6 7 8 9, that is 512 is equal to 2 power 9. So that implies 2 power x is equal to what? 2 power 9. Since bases are same, powers are, since bases are same, powers are equal. That means x is equal to what here? 9. Okay, log 0.01 to the base 10 is equal to x. So this can be written as 10 to the power of x, that is 0.01. Okay, so 10 to the power of x is equal to, this can be written as 1 by, after 2 places you have decimals. Okay, 10 to the power of x is equal to, this can be written as 1 by 10 square. When you shift this to the numerator, it becomes 10 to the power of x is equal to 10 to the power of minus 2. Since bases are same, powers are greater. Since bases are same, powers are equated. That means what you are going to get here is equal to minus 2. For the examination point of view, this carries 4 marks students. For essay type questions, long answer questions, you are going to get it. What is the question given here? X square plus y square. If x square plus y square is equal to 25xy, then we need to prove that 2 log x plus y is equal to 3 log 3 plus log x plus log y. So first and foremost, what is our duty? We need to write the given problem. What is given here? Given is equal to x square plus y square is equal to what? 25xy. Okay, right. Take this as to be the equation number 1. So when you observe here towards the right hand side, what is given? We need to do 2 log x plus y is equal to 3 log 3 plus log x plus log y. We just observe the logic. It is in the form of x square plus y square here. So how do you get 3 log 3 plus log x plus log y? When you add 2xy on both the sides. So adding 2xy on both the sides, what you are going to get it? Add and check it. X square plus y square plus 2xy is equal to 25xy plus 2xy. So that implies this is the form of x plus y whole square, which is equal to what? 27xy. Now take this as equation number 2. So for whatever the given equation is there, we need to apply logarithms on both sides. Apply logarithms on both sides. On both sides. If you apply logarithms on both sides, what you are going to get, students? X plus y log x plus y square is equal to log 27 xy. So log a to the power m. This is in the form of log a power m. That is m log a. That is equal to. This is in the form of log ABC. What is log ABC? Log 27 plus log x plus log y. So this 27, can I write it as log 3 cube plus log x plus log y? That implies we will be getting 3 log 3 again a power n. 3 log 3 plus log x plus log y. Therefore, that implies 2 log x plus y is equal to 3 log 3 plus log x plus log y, which is our RHS, which is equal to RHS, hence proved. The next question is, if log of x plus y by 3 is equal to 1 by 2 log x plus log y, then we need to prove that find the value of x by y plus y by x. This question is also very important for the long answer type question, which is for 4 marks. So please observe this problem before solving. Okay. So what is given? Given is equal to log x plus y by 3 is equal to 1 by 2 log x plus log y. This is our equation number 1. So that implies, can I write this equation number to be log of x plus y by 3 is equal to 1 by 2. This is in the form of log a plus log b. Can I write it in the form of log ab log xy? So that implies log of x plus y by 3 is equal to, I can write it as log xy to the power of 1 by 2. The logarithms are there on both sides. So let us cancel that logs on both the sides. If you cancel that logs, you will get x plus y by 3 is equal to xy to the power of 1 by 2. Because only logs and logs are cancelled here. So it will be remain that. Now we do what is that one? X plus y by 3 is equal to root of xy. Xy whole to the power of 1 by 2. That means x plus y by 3 is equal to, what is that one? We are going to cross multiply here. X plus y is equal to 3 into xy. Now take this as equation number 1. Now square is there. So in order to remove that square root, you are going to square it on both sides. You square it on both sides. That is squaring on both sides. If you square it on both the sides, what you are going to get, students? X plus y whole square is equal to 9 into xy. So that implies, now this is in the form of a plus b whole square. Expand that. X square plus y square plus 2xy is equal to 9xy. So that implies x square plus y square is equal to, shuffle this 2xy towards the other side, you get 7xy. Okay. What will be our next step? X square plus y square by xy by x square plus y square by xy is equal to 7. Okay, so that implies you are going to get it x square by xy plus y square by xy is equal to 7. Your x cancel, so you are going to get it what? X by y plus your y by cancel, you will get it y by x, which is equal to 7. So therefore the value we are supposed to find out x by y plus y by x is equal to 7. So the value obtained is